Hello, I'm Paco Muñoz. Let me explain active replication. The goals of this presentation are to identify the active replication characteristics, to apply the advantages of this replication model, and to avoid its inconveniences. The contents of this presentation are structured in this way. Let's start. There are two classical replication models. In the passive one, there's a primary replica that receives all client requests. It processes all the instructions in each one of those requests, and eventually it completes that execution. At that time, it propagates all the updates to the remaining replicas. Those other replicas are known as backup or secondary replicas. On the other hand, in the active model, all replicas behave in the same way, so requests should be delivered to all the replicas, and they all will process each one of those requests and will send an answer to the corresponding client. Both models are able to provide strict consistency. However, also, both models may be relaxed. In those cases, they increase their throughput and they provide sequential consistency. Let us explain the active model. In the active replication model, also known as state machine replication, clients send their requests to all server replicas. Each server replica directly processes all the instructions in those operations. So, they don't need to exchange any update propagation, because all they behave in the same way. Eventually, each replica ends the list of instructions for that operation, and each one sends an answer to the client. Graphically, we have a client that broadcasts its request to every replica. Then each replica executes all instructions in that operation, and eventually each one sends an answer to the client. All replicas behave in the same way, so they all will maintain the same state. The advantages of this replication model are the following. There's a trivial reconfiguration in case of failures, basically because all replicas behave in the same way and all of them have the same state. But the requirement here is that we should keep at least a minimal amount of replicas once there's a set of failures. Here, the arbitrary failure model is also tolerated. Assuming that there may be up to f simultaneous failures affecting to f nodes, we should have at least 2f plus 1 replicas. And we need this number when replicas may identify themselves without any ambiguity. To this end, we should use a certification mechanism. In that case, clients wait for at least f plus 1 identical, that is correct, answers. In the general case, we'll need instead 3f plus 1 replicas, because replicas may try to adopt the identity of another one, mainly in case of a failed replica, that is, a replica that behaves in an arbitrary manner, and in that case, those replicas adopting the identity of others send their replies with that other identity, and the client will receive two answers with the same sender. In that case, the client should discard both answers. Because of this, we wait for at least f plus 1 identical answers, and we should have more than 3f replicas. The inconveniences are the following. When a strong consistency is needed, requests need to be broadcast to all replicas. And besides this, that broadcasting should be in total order. And that requires consensus, and consensus requires a heavy protocol. So, in the end, this penalizes throughput. The second inconvenience is that non-deterministic operations cannot be admitted. A deterministic operation is one that, given the same values for the arguments, always returns the same result. But non-deterministic use some random source in its logic, and because of this, for a given combination of arguments, it may return each time a different result. So, if we used non-deterministic operations in this replication model, then we would generate different results in different replicas. And because of this, those replicas may get inconsistent among each other. When actively replicated services interact, requests should be filtered. Let's see an example. Let's imagine that service A calls service B, and that both are actively replicated. So, here, if A calls B, B should filter the many requests that it will receive. Indeed, here, using 3 replicas for each service, each instance of B will receive 3 identical requests. So, it should filter those requests in order to get a single execution of those requests. Responses from B to A should be forwarded to all replicas of A and should be also filtered, as depicted in this scenario. Let's conclude. Once this presentation is ended, the student should be able to identify the active replication characteristics, to apply the advantages of this replication model, and to avoid its inconveniences.